This way. 30, 45, 60, 90 still. So 180 plus 30, 210. 180 plus 45, 225. 180 plus 60, 240. 180 plus 90, 270. Then we work our way back to the 360. That's not where that's supposed to go. Sorry. 360. And then we do our reference angles. 360 minus 30 is 330. 360 minus 45 is 315. 360 minus 60 is 300. We agree? Now, whenever we're converting from degrees to radians, we want the degrees to cancel, correct? So am I going to multiply by pi over 180 degrees, or 180 degrees over pi and get degrees squared? I want the degree symbols to cancel, correct? So what am I multiplying by? Pi over 180. So could I not just do this? Everyone follow up. So these ones match. This one's going to be 0. This one's going to be 2 pi. Okay. Could I not just divide these all by 180 and add a pi to the top then? Yep. Yes. So go 30 divided by 180. Math, enter, enter. Add a pi to the top. What do you get? You get 1/6, right? So if you get 1/6, it's pi over 6. Then 45 divided by 180. Math, enter, enter. 1/4. So it's pi over 4. Yes? So you can take every degree divided by 180, math, enter, enter it, and you'll get every fraction, add the pi to the top. Correct? Go do the rest. Go. So let's go through this. 60 divided by 180 is pi over 3. 90 is pi over 2. 120 is 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. 180 is pi. 210 is 7 pi over 6. 225 is 5 pi over 4. 240 is over 3. 4 pi over 3. 3 pi over 2. What? What's 300? Yeah. What's 315? What's 330? And then 5. Okay? Then we go, okay, from all over 2, 3, 2, 1, 3, 2, 1, where's square roots? Square roots? Yep, that's what we're going to, no! You get a little flustered. Okay, so when I teach it in grade 11, when I used to teach grade 11, I always taught it with memorization, absolutely 100%, because it was too overwhelming to teach it any other way. However, you now, I believe in you, can fill in a unit circle memorized. I'm very proud of you. Now we have to transfer to, do I actually understand what the heck I did? Okay? So, this is the mind-blowing part. Just wait. People are like, I don't know if it's root 3 over 2.5 or a half of root 3 over 2. I don't know. I don't know if it starts with that. And then you get all flustered. All right. Ready? It's going to be crazy. It's a 1-by-1 box. We agree? So, these are all coordinates, and the coordinates are just connected. What is this coordinate on a 1-by-1 box? 1 and true. You guys are all good with that. And then you guys rocket this one. This one is 0 and 1, because this is a 1-by-1 box, correct? And then this is a coordinate on a Cartesian plane. It's just a really tiny, like, it would be like you have this huge graph paper and these little tiny boxes, right? Would make up your unit circle. This one is what? -1 and 0. And this would be? Okay. Now, we know this, right? We know one of the coordinates is root 3 over 2.5. We know one of the coordinates is a half of root 3 over 2. And we know one of the coordinates is root 2 over 2, root 2 over 2. We know those are our 3 options we have. Okay? Because we did, you guys would have done special triangles last year to understand this. So root 2 over 2, root 2 over 2 was a 45, 45, 90 triangle because you got the same ratio when you did cos and sine. Your other options are root 3 over 2.5. And then you have a half of root 3 over 2. That's it. Literally, fill in the rest of the unit circle. And then appropriate signs based on what quadrant you're in. If you're in quadrant 1, x and y are both positive. If you're in quadrant 2, x is negative, y is positive. Quadrant 3, both negative. Quadrant 4, x is positive, y is negative. Yes? All right. These are both 0.707 as a decimal. They're the exact same value. We agree? Okay. So let's go back to the unit circle. Which one of these three coordinates actually has the exact same x and y value? Yeah.
45.
All the 45s. If you look at it, this is a 1 out to here, correct? This is a 1 up to here, yes? If I count this over and I count this over, they're actually equidistant to 1. Do you see that? They're 0.707. So every single 45-degree reference angle will be root 2 over 2, root 2 over 2. And then the sign will be dependent on what quadrant you're sitting in. We agree? Okay. So this is root 2 over 2. This is root 2 over 2. And then we're going to learn to check these after. This is going to be negative root 2 over 2 and positive root 2 over 2 because our x is negative here and our y is positive. These are going to be negative root 2 over 2 and negative root 2 over 2 because we're in quadrant 3 and both x and y are negative. And this is going to be root 2 over 2 and negative root 2 over 2. Okay. We know the other coordinate options we have are root 3 over 2 and a half. Yes? Or a half of root 3 over 2. And then I get people putting them in the wrong spots. And they should never be in the wrong spots because you are literally giving a coordinate. Yes? Just so you know, root 3 divided by 2 is 0.8660. A half is 0.5. Correct? So let's look at our coordinates that I was talking about. This one would technically be like 0.8660. That is not an exact value though, right? This is an exact value. And 0.5. So that's one of my coordinates. Or 0.5 and comma 0.8660. Remembering that the first coordinate represents the x and the y is the second one. Yeah? So let's go back to our unit circle. This coordinate, is my x at 0.866 or is my x at a half? Remembering that the distance to here is 1. So let's look at the x value. Is my x at 0.866 or is that halfway between 0 and 1? It's 0.866. So my x is what? Square root 3 over 2. Let's follow my y. Where is my y? Halfway between 0 and 1. So my y is a half. Should I be memorizing or is that coordinate? Correct? Yes, we're memorizing root 3 over 2 and a half to a point because we've done the 30, 60, 90 triangles that got us to a half and root 3 over 2 by using SOHCAHTOA. But that makes sense that that's root 3 over 2 and a half. And that's a 30-degree reference angle, correct? Every 30-degree reference angle is going to have that coordinate because that coordinate is the same distance. Except on this side, my x is what? Negative. This is going to be negative 0.866, correct? And this is still positive a half. Do you see that? So this is negative root 3 over 2, and this is a half. This coordinate would be negative 0.8660 and negative a half. And then this coordinate here is positive root 3 over 2 and negative a half. We agree? Does that make sense? Because it's a coordinate on a 1-by-1 grid. Yeah? Okay, let's look at our last one. Obviously, it's a half and root 3 over 2, but obviously means just because we're red out of stuff. Well, let's actually explain why. So if I follow this down, what's my x? A half. That coordinate's a half. What's my y? Root 3 over 2. Correct? So should you ever accidentally put them the wrong way? No? Also, we're going to be checking some of our work in a second here, but this can be a half and root 3 over 2. When we're done, we will always run test points to check that our unit circle is not wrong. And I'll show you how. Sorry, it's a negative. right? They're all coordinates. So, even though I don't know the answer to 345 would be somewhere over here. Even though I don't know the answer to 345 degrees, I do know that my x is going to be larger than 0.866 and my y is going to be less than -1/2. It would be like negative whatever, right? So if I'm given multiple choice options and the one is like 1/2 and something else, well, that's gone because I know that that wouldn't be correct because these are all coordinates. Like 345 would be here, 359 would be here, so we're really close to having 1, 0, correct? So there are way more coordinates on this unit circle. There's an infinite number of them on that unit circle. These are just the only ones I can ask as exact values. Are you listening? Yes? On the unit circle, coordinates are Calgary Stampede, cos, sine. So up here, we're going to put this for ourselves. It's cos theta, sine theta. Every coordinate gives you the answer to cos of that angle and sine of that angle. That's what you're getting. You're getting trig ratio. Remember, your teacher taught you in a 30, 60, 90 triangle or a 45, 45, 90 triangle, and that's how you get those ratios. Because sine is opposite over hypotenuse, right? So you're going to get 1 over root 2 when they did it, which rationalizes to root 2 over 2. So it's from triangles that you're getting these ratios. These are all cos ratios and sine ratios. If I need tan, I go to my formula sheet, it's sine over cos, so I have sines and coses. So literally, if I ever ask you sine of an angle or cos of an angle, and it's one of these 30, 45, 60, 90 reference angles, you can give me answers like that. Okay? If I ask you for sine or cos of anything that's not directly on here, like say 12 degrees, I could get the coordinate at 12 degrees, but I would have to do cos of 12 degrees, sine of 12 degrees, because cos of 12 degrees gets you the x of the coordinate, sine of 12 degrees gets you the y. Yeah?
We can use radian or degree method.
12 degrees.
Okay.
Yes. But if it was just 12, sine of 12 or cos of 12, then I would have to use radian. All right. That would be an aggressive turning thing, but that's okay. All right. So we're going to run some test points. I want to know if this coordinate's correct. So this coordinate is actually cos of what? Cos of 30 degrees, comma, sine 30 degrees. So instead of writing those answers, root 3 over 2.5, could I not write every coordinate as cos of that angle, sine of that angle? Could I not? Okay, I'm going to press the cos button. I'm going to slap my hand, and I'm going to say I need to be in degree mode. If you picked pi over 6, what would you have to be in? So if I went cos of 30, everyone types in, go cos 30, make sure you're in degree mode. What do you get? 0.8660, which is root 3 over 2. Now, do sine of 30. Sine of 30 is 0.5, which is 1/2, okay? Change it to radian mode. Do cos of pi over 6. Make sure you're in what mode? Yeah. So if someone doesn't listen to me and they're like, I didn't get that, and there's a degree stuff. So cos of pi over 6 is 0.8660, which is root 3 over 2. Sine of pi over 6 is 0.5. Okay? If you have it in the wrong mode, it does not come out as these answers. So if you actually go cos of pi over 6 in degree mode, you're going to be wrong and you're going to think you're wrong just because you're in the wrong mode. Because what it's doing when it's in degree mode is cos pi over 6 degrees, which is not that same spot. Okay? All right, I want you to test these ones out. I want you to go here, and I want you to go cos of what? I'm doing this one. What's it going to be? This coordinate. Cos 135 degree symbol, sine 135 degree symbol. Don't forget the degree symbol, because if you forget the degree symbol, you are doing radians. Make sure you're in degree mode. So you're going to get negative 0.707 and then 0.707, correct? So these are the exact values I can ask you. The 30, 45, 60, 90 reference angles, that they can be outside of 360 as well, right? Like I could give you 750. 750 is a 30-degree reference angle in quadrant 1. So 750 is going to give me this exact same answer. So coterminal angles will terminate on that same coordinate, correct? If you terminate on that coordinate, that is the answer, right? So 750 is going to give you the exact same answer. Cos 750, sine 750 is going to be this coordinate because it's going to land on that one. Yes? Another one would be 390. Cos 390, sine 390. Yes? Another one is negative 330. Still will land on that same spot. So cos of negative 330 and sine of negative 330, exact same coordinate. That's why coterminals are important. They land on the same spot as your unit circle. Yeah? All right. Those are exact values. But what if I ask you for for the coordinate at 112 degrees? I want the coordinate at 112 degrees. Okay? If I go back here, I know 112. Cool, this is 135, this is 150, that's 120. It's about here. So I'm just going to randomly guess. Would that help me out? Could I ask for the exact value at 112 degrees? No, because it's not on the unit circle. It's not a reference angle of 30, 45, 60, 90. But I can ask for answers. How would I get the coordinate at 112? What are coordinates on the unit circle? Cos of that angle, sine of that angle. So I would go cos 112 degrees, sine 112 degrees. Cos 112 degrees, sine 112 degrees. Sometimes that's just the answer. More often than not, though, it's a decimal. So they would say to 3 decimal places. They'll give you multiple choice. You put cos 112 in, there's going to be a decimal. Sine 112, there's going to be a decimal. Can someone give me cos 112 degrees to 3 decimal places? 0 point, pardon?
4, 5, 6. What? Oh, I'm in radius.
0 point, pardon?
Negative 0.27.
Yeah.
Okay, and then what's sine of 112?
927.4.
927? Okay, let's see. Does this make sense? It should make sense to you. You guys just randomly go and do math, but don't ever check if it makes sense. So let's go back. Okay, 112 would be somewhere like here. Okay, the y would be 0.927. This is 0.866. Would that look like 0.927? Possibly, right? Because this is 0.866 up to here. This is 1. That could be 0.927. Okay, and then my x is negative 0.375. Okay, well this is an x of a half. Negative a half. Negative 3. Yeah, seems like it could be realistic. It should make sense to you. Everything should make sense. You should understand why you do what you do. Okay? Does that make a little more sense to you? The last thing I want to go over is circle formulas. You weren't asked circle formulas. Back in 2000, before the new curriculum came out in 2012, you were wee little lads and lasses. Lassies? I don't know what you are. But anyways, I'm really bad at English, so you can figure that out. All right. So, in 2011, let's say, when the old curriculum was in, we used to have to do conics. Conics made us find equations of circles. And we had to do it of ellipses, which is like an elongated circle, this way or this way. And we had to be able to transform them and move them. That's out. All we really care about, the only circle we care about, is the unit circle. Okay? So I want you to pay attention. You're not writing anything down. A circle formula is x minus h squared plus y minus k squared equals r squared. Okay? That is the formula for a circle. You don't really care. But I'm explaining to you why the unit circle formula is what it is, rather than you just trusting me and having no idea why. So, h and k represent the center. R, what do you think R would represent on a circle? Radius. Ah, genius. So, what is the center of the circle at the unit circle? It's 0, 0. True statement. So that's my H and my K. What is the radius of the unit circle? 1. It's 1. It's that little 1 by 1 block, right? You said 0. You said 1, 0, 0, 1, negative 1, 0. It's 1. So R equals 1. So when I go to do the formula, I'm going to get x minus 0 squared plus y minus 0 squared equals 1 squared. If I make it look not so stupid, it's just x squared plus y squared equals what? 1. Every coordinate on your unit circle, if you square the x and you add it to squaring the y, you should get 1. If it doesn't equal 1, it's not on the unit circle. It has a radius that's bigger or smaller, correct? So if you square your x and you square your y and you get a number less than 1, your unit circle is here and the coordinate is within the circle. If you have a radius, you solve for your x squared plus y squared and you get a radius bigger than 1, here's your unit circle. The coordinate's outside the unit circle because there's a radius bigger than 1. Yes? Because that radius flows around. Does that make sense? All right. So let's go to our notes. You guys are here. Always read our guiding words, understand what the heck it's asking us for, and there are always some hints to words that are given to you. If it ever says on the unit circle, that means it has to fit that formula, correct? She's talking about how I got. See? Look at this. She got the service with a smile.
Thank you for your support.
Thank you. Super really fine artsy. I will teach dramas.
Yeah.
No one would stay. No one would stay. Also, if I got English. Whew. Bless the children. All right. So, unit circle, if it says on the unit circle, that means we can do two things. Let's think about this. If it says on the unit circle, we're going to write this up here, on the unit circle. On the unit circle means two things. If it's on the unit circle, what is the equation of the unit circle? We just went over this. X squared plus y squared equals 1. So if something is on the unit circle, I know I can use x squared plus y squared equals 1. I know that's a true fact. I also know that every coordinate on the unit circle follows what? Not wrong, not where I was going for. Calorie stampede. Every single unit circle coordinate is what? Cos of an angle, comma, sine of that same angle. Yes? So I know if it's on the unit circle, I can use that formula. I also know that every coordinate on the unit circle is cos of an angle, sine of an angle. So if they're ever asking for coordinates, if it's directly on there, I can just go pull them off. Like in 45, if I've drawn my unit circle correctly, I go to 45, just take that coordinate off. Yes? But it is also cos of that angle, sine of that angle, so I can always check with my calculator as well, as long as I remember to change my modes. So, here it says state. State is always a one-mark question. State is, tell me what it is. So, if you just give an answer, that's good for state. If it says determine, and you just give an answer, you have determined nothing. You've stated. Those are very different. Determine means show a process as to how you got that. Okay? So if it said determine, I wouldn't be able to just go on my unit circle and state the coordinate. I would have to go, at minimum, cos pi over 2, comma, sine pi over 2, then give the coordinate to that. So you're actually showing how you're determining it. You know what I'm saying? So here it says state. I don't have to do that. State the coordinate of the intersection of the terminal arm, so where it stops, and the unit circle. I'm given the following. So pi over 2, I know if I go to my unit circle and I look up at pi over 2, which is 90 degrees, it is at what? 0, comma 1. If that falls out of my head, what could I just do? Cos of what? Cos of pi over 2, comma, sine of pi over 2. Fun fact. Cos pi over 2, sine pi over 2, cos of pi over 2 is 0. Sine of pi over 2 is 1. They are the same thing. Yes? So your unit circle, although it looks like it's a coordinate, you can pull coordinates off of it, but you can also pull trig ratios off of it. The trig ratio, so sine pi over 2, the answer to that is 1. The answer to cos pi over 2 is 0. So every single x value on your unit circle is the answer to cos ratios. Every y value is the answer to sine ratios. Yes? So you have immediate cos and sine answers like this, just on your unit circle at all the reference angles of 0, 30, 45, 60, and 90. Okay? Any other ones, you'd have to use your calculator. Okay, negative 3 pi is a lovely little thing, but negative 3 pi, this is what I always do. Everyone listening, you can do it how you choose. You can draw if you want. You could actually draw negative 3 pi and see that it lands on pi. You could do that as well. Or what you can always do is your unit circle fits between 0 and 360 degrees, yes? And it fits between 0 and 2 pi, yes? So what did we learn yesterday that could help us with today? What could we do? You know? Yes. You could add 360 minus 360, add 2 pi minus 2 pi, get the coterminal that would land on there, correct? So I know this is in radians, bless you. So I want it to get more positive, so I'm going to add 2 pi to it. Negative 3 pi plus 2 pi is negative pi. Guess what? Negative 3 pi and negative pi have the same answer. Okay, let's add 2 pi again, because it's still on my unit circle. What does this equal? Pi. Watch this. Cos of negative 3 pi, comma, sine of negative 3 pi, cos of negative pi, sine of negative pi, and cos of pi, sine of pi. Fun fact, all of the same answer. They terminate on that same coordinate, every single one of them. What is the coordinate at pi? What's my coordinate?
-1, 0.
-1, 0. Did you know that all 4 of these 4 things, are all the exact same? They're all -1, 0. Because they terminate on that same coordinate. Yes? That's why the coterminals of yesterday were so important. Because anything that terminates on that same arm lands on that same coordinate. Because negative 3 pi, if you see the unit circle in front of me, negative 3 pi would be like this. Negative 2 pi, negative 3 pi. Oh, it lands on this coordinate. Negative pi. Oh, it lands on this coordinate. Positive pi. Oh, it lands on this coordinate. All 3 of them land on the exact same coordinate, which is -1, 0. Yes? So if I get an angle that's outside of my domain, 0, 2 pi or 0, 360, I just find the coterminal of it that lands in there. But you can draw it and just see that it lands on there too. There's nothing wrong with that. Okay, make a little bit of sense? Okay, go. I want the coordinates of the rest. There's a whole lot of them. I do want you every single time, though, guys, I want you to do this so that you're checking it. I want you to go cos 7 pi over 2, comma, sine 7 pi over 2. So I want you to find it on the unit circle first, but then I want you to check it with your calculator. And some people will say to me, well, Ms. Lepp, why can't I just use my calculator? I don't need this. Because if I ask you to determine or show any work, you're in trouble. Because you only know your calculator. Okay? So check with your calculator, find it on your unit circle first. Okay? I will always just add 2 pi's or subtract 2 pi's till I get myself the radian that lands on it, or I'll add 360s or subtract 360s. I don't convert. The reason why I don't convert is converting takes 17 more years, and secondly, you can make an oopsie the more steps you do to try and get yourself in. However, if you're somebody who can't do it without converting, convert, right? But I'm just going to show you how I can just get the coterminals if it's in radians by coterminaling it. That's not a thing, but it's an actual word of mathematics I just made up. By coterminaling it, is what we're going to do. Okay, 7 pi over 2 is too big, so I'm going to subtract 2 pi. Remember, you can make common denominators so you can actually subtract it, or you could go 7 over 2 minus 2, just not put the pi's in, put the pi back in after. Anyways, 7 pi over 2 minus 2 pi is 7 pi over 2 minus 4 pi over 2, so you're going to get 3 pi over 2. The coordinate at 3 pi over 2 is 0 and -1. 720, you could visualize it turning, but if that's too much for you, you could subtract 360. It is too big. Oh, I subtract 360, I get the answer at 360. The answers at 720 and the answers at 360 will be the exact same, because they land on the exact same spot, because they are coterminal, which is why coterminal is so important. So, at 360, my coordinate is 1, 0. 60, my coordinate at 60 is 1/2 and √3/2. 7 pi over 6 lands at 210. I just know to memorize the different decimals, but that's fine. So it's going to be a 30-degree reference angle. So if it's a 30-degree, I'm going to get negative a half. Nope, negative root 3 over 2, sorry. And negative a half. 240 when you go to that on the unit circle. It's a 60-degree reference angle, so it's going to be negative a half and negative root 3 over 2. Negative 330 is too small, but you could just go like this and find out that it's at the exact same spot as 30, or you could add 360 to it to get its coterminal, and that would be 30. The answer to 30 is a half and root 3 over 2. That's a lie. Root 3 over 2.5. My brain is, no, please don't freeze. I'm just going to borrow the next classes. Alright, this one is root 3 over 2.5. And I could check this, because I could go cos of negative 330, comma sine of negative 330. Do we agree? They can be checked. I shouldn't have to even give you the answers. Yes? Because you should be able to check them. Negative 5 pi over 3, I'd have to add 2 pi, or 6 pi over 3. So it's the same as pi over 3, which is 60. So it is going to be half and root 3 over 2. 19 pi over 6, I would have to get minus 12 pi over 6, which is 2 pi in common denominator. So it's 7 pi over 6, which is the same answer to this one, which was negative root 3 over 2. Negative a half. 570, I'd add 360 to it. So I would get negative 210. I'd add 360. And I get 150. And 150 is 30-degree rectangle, so it's negative root 3 over 2.5. And we did this one already, Nate. Okay. Principal angle, once again, reminding you if they ever ask for the principal angle, it's the smallest positive angle between 0 and 2 pi or 0 and 360. Okay. This one says determine the value of angle theta in standard position. So what do we do first? I gave you angles, ask for coordinates, correct? Now I'm giving you a coordinate, asking for the corresponding angle. If I do that, I have to give you a restricted domain, or you have to give me all the solutions, right? So this is a restricted domain between 0 and 2 pi. I get a whole bunch of people like, oh, negative 1, 0. Negative 1, 0 is here. Okay, 180 degrees. How much marks are you getting? 0, because what was my restricted domain in? Radians. So I can't give this answer. What would I have to give? Pi. So my restricted domain is from 0 to 2 pi. It's all the answers on your unit circle, but the radian answers. Also this one, want to draw your attention to this. Negative 1 over root 2 is the unrationalized version. So I would rationalize my denominator by multiplying by root 2, top and bottom. And so I would get negative 1 root 2, which is negative root 2. And then what's 2 times root 2 times root 2? Root 4, which is 2. So this is actually the same as negative root 2 over 2, comma root 2 over 2. So you have to remember when you see this, that is the same as this. It's the unrationalized version of your 45s. Yeah? Okay, give me the answers. So root 3 over 2.5 is in quadrant 1. They're both positive. So it's going to be pi over 6. This is a negative and a positive, so it's in quadrant 2. Quadrant 2 with a 45 degree, so it's going to be 3 pi over 4. And then this one's in quadrant 3 because they're both negative. It's a 60-degree reference angle because it starts with a half. So it's going to be 4 pi over 3. I have the unit circle and all of its things memorized, but my childhood memories have left me because this is replacing it. Did I even go to kindergarten? I don't know. Did my grade by like grade 1? I'm not even sure. Is that a memory? I don't know. My brothers broke my leg. I broke my, well, my brother,
So you
my
didn't-
brothers caused my one brother to break my leg.
Oh,
You wanna know how?
yes, we did.
So, when you know, oh. Good choice. Okay, so here it says, determine the missing coordinate for each point on the unit circle. So if I see on the unit circle, I know I can either go to the unit circle or I can use that formula. We talked about this, correct? So if I know, and we explained why, here's why, I don't need to do that again. I explained how you got the unit circle coordinate or formula. But this is going to go into that formula. So I'm going to get this is my x, my y stays a y, and my r is 1. That's how it became a 1 over there. So I get negative 4 over 5 squared plus y squared equals 1. Yes? Then I get 16 over 25 plus y squared equals 1. Then I'm going to subtract my 16 over 25 over. So I'm going to get y squared equals 1 minus 16 over 25. Then I need a common denominator. So I get y squared equals 25 over 25 minus 16 over 25. So I get y squared equals 9 over 25. And then I take the square root. What do I do when I physically take the square root? We've talked about this. Plus or minus. And 9 and 25 are perfect squares, so I get plus or minus 3 over 5. Now that is my answer unless they give me a quadrant. Oh, they did. They told me it's in quadrant 2. What are y values in quadrant 2? Positive, right? Quadrant 1, y's are positive. Quadrant 2, y's are positive. 3 and 4, they're negative. So my answer is actually 3/5. Let's look at B. So B, I have an x, y, it's in quadrant 4. So I'm going to go 3 over 10 squared minus y squared equals 1. So I get 9 over 10, and by 10 I mean 100, minus y squared equals 1. And it's a plus sign. Why am I putting a minus? Because I'm rushing. Y squared equals 100 over 100 minus 9 over 100. So y squared equals 91 over 100. Now we're going back to grade 10. We always end up in grade 10. We always go back to grade 10 curriculum. It's what we do. We do math and then we finish almost everything with grade 10 curriculum. So I tell all the 10Cs they need to learn their math. So in grade 10 you were taught same thing, square root plus or minus. But what you were taught about the square root is you can split it. You can split that square root. You can write it as an entire radical, or you can write it with the radical in the top and the radical in the bottom. So I'm going to split this one. This one was, I could write it as all because the whole thing was perfect squares. This one, I'm going to go y equals plus or minus root 91 over root 100. Why would I do that? Because 100 is a perfect square. So if one of them is a perfect square, you would split them. So now I would have root 91 plus or minus root 91 over 10. Right? If you don't believe me, you could go root 91 over 100, get a decimal, and then go root 91 over 10. They'll be the same decimal. Don't believe me. Okay? Same answer. So, we know it needs to be in quadrant 4. We know it's y. What is y in quadrant 4? It's negative. So we're going to get y equals negative root 91 over 10. And your homework is, oh, we'll do this one. Determine if the following coordinates are on the unit circle. How do I know if something is on the unit circle? If it doesn't equal 1, it's outside the radius. If it's less than 1, it's inside the radius, right? So we're going to go 0.65 squared plus negative 0.76 squared equals 1. And then I believe you get 1.001 or 0.001. This?
Yeah.
So people tell me that's close enough. Yay, it's on the unit circle. No. The radius is 1. 0.0001 is just so outside of it, correct? So is it on the unit circle? No. Therefore, not on the unit circle. And you can use the 3-dot triangle, because that is mathematically sound, to mean therefore. there's lots of symbols in math we don't use that you will when you're in university. That mean things. So, 4.2, the unit circle homework stuff. It's not long, it's just this. Okay?